Hello guys and welcome to a really special series on my channel, Are We Alone? So we haven't uploaded in a while and I know we haven't uploaded, and I have told you the reason because I have exams, and as promised I am back on this month. Well, today's video in Are We Alone is really different, so it's like a sub-series in the series. What I'm going to be discussing about is the great escape of humanity over here. So this is going to be a really long video, so I decided I'm not going to collect as many pictures and not many starting off thumbnails and stuff like that, because in this I have to elaborate a lot and I cannot get everything perfect, so there might be some mistakes in my pronunciation or I might miss a few points because it's a long one. Well, you guys have to excuse me for that. So yeah, without further ado, let's just get into this video. And I only have 3 pictures for about a 20-minute video or something, because I'm going to try to make this a long one. So yeah, hopefully you guys enjoy, and let's just get into the video. So the fate of our planet is always not in our hands, guys. Well, you guys might have seen many pictures saying the fate of our planet is always in our hands, save the environment. Well, yes, the fate of our planet is in our hands to some extent. After that, we can't really do anything. Let's say that a huge asteroid is coming. You guys must have seen that we'll use nuclearites and bombs and deflect it off its trajectory or just blow it up. That's true for a size, maybe a 30-story building asteroid. But anything bigger than that, a nuclearite can't really do anything to it because it's more powerful. Or a neutron star coming into our solar system and blasting Earth. Or a black hole coming in. So any of these phenomena can happen. So today we're going to be taking a phenomenon saying that a neutron star is coming to our solar system in 75 years, and this neutron star is going to explode Earth. So we can't really do anything. Nuclearites, nothing can deflect a neutron star. What a neutron star is basically when a huge star dies after a supernova, 2 things happen. A black hole is created or a neutron star is created. So both are really powerful. And when a neutron star is heading towards Earth, there's so many gamma rays and radiation coming to Earth. So it's a bad start off as well. So we can't really do anything. So what do? If the human race has to live, and we cannot always live to the confinement of our planet, we have to break the boundaries. We have to leave Earth to find a new home. So the second I see that sentence, like we have to leave Earth, there's so many theories and so many questions going on. Where do we go? How long do we go? How do we go? And what's going to happen? So today, let's step by step go through all these things and let's come to a conclusion, and hopefully it's fun and I'm enjoying it as well. So yeah. So when the theory comes of interplanetary travel or outer space travel, you guys might be thinking about rockets, which are here on your screen for a long time. So the reason they're here is because to make this journey, these rockets aren't gonna help at all. Clearly, obviously, the rockets and the machines we have now, you're not gonna get anywhere with them. Say for example, the Voyager probe. That is the fastest man-made object till date. It's traveling at the speed of 17 kilometers a second. That's right, 17 kilometers a second. But that's only 0.006% the speed of light. So that is so fast, but it's so less compared to the speed of light. And the nearest solar system, Alpha Centauri, is 4 light years away. So at the speed of light, it will take us 4 years to reach there. Now consider reaching there at the speed of 0.006% the speed of light. It will take so long. And the maximum traveling time I have kept for this voyage is 4 generations. Now let's say, every generation depends upon how fast you marry and stuff, but I just kept an average of 50 years per generation. So let's say about 200 years on the spacecraft itself, right? So that is a pretty decent long time, right? Yes, it is. So what are we gonna do? Well, we have to make a machine which is going to travel fast. And obviously, we're not going to go to Alpha Centauri because Alpha Centauri has a planet named Proxima b, but Proxima b is in the habitable zone for some parts of the year. So we're looking for a planet which is in the habitable zone for all the year and not that far. Kepler Space Telescope has found a bunch of these planets, but the problem is the range Kepler is looking at is about 500 to 1,500 light years, which is quite a lot, to be honest. So that is not an option. So where do we go? According to my space knowledge of studying space for over 3 years now, I could tell you there is a star. Recently discovered in 2016, it's called TRAPPIST-1, and it's really famous. It's famous because the star not only has one planet in the habitable zone, but 3 planets. So personally for me, this is a huge candidate to go to. So let's just say the aim is TRAPPIST-1. What do we do? There are a bunch of options of how and where we're going to go with what machine. So clearly this machine is not going to be useful, so we have to make something else. So we could make a sail, a solar sail. What is a solar sail basically? A very big solar panel, say the size of a 45-story building or so, is just sailing across the cosmos. Well, that is really fast, but there's a drawback. It's only good to travel in the solar system because the sun's heat travels that far. Anywhere out of the solar system, and eventually the heat and the sun's light won't reach. So you're going to be running out of fuel pretty fast. So we're going to cancel that out of all the list. The next is trying to use antimatter. To all of you who don't know what antimatter is, it is the opposite of matter and it can explode when it contacts in matter. So that is when it gets contacted with matter, but that is a really basic explanation. Anyway, so antimatter is not safe to use because we need to create a magnetic field to store it. And to store a huge amount of antimatter, we will really never store it properly, and even if it explodes in the tank, that is fatal, we'll all die. It's not at all safe. So there is a way we could accelerate up to 7% the speed of light. But this way is not modern or high-tech or something. It's 60 years old. It came from the time of World War II. The same thing which blasted over Nagasaki and Hiroshima, the nuclear bomb. Yes, I'm right. I'm talking about the nuclear bomb. So we could create a huge ship and have a separate compartment on the back of the ship, which is completely different from the ship but still attached to it, and have a set of 3 nuclear bombs explosions every minute for 10 days. So then we could accelerate up to 7% the speed of light. So that is pretty good compared to what we have now, and that is the best way we could go. But this is quite hard because that separate component has to do a variety of things. We wanted to do 3 major things perfectly so that we could pull this off. 1, it has to protect us and itself. So 1 is it has to protect us because where nuclear bombs are 3 bombs a minute, blasting is not a really healthy environment, so we could protect ourselves with shielding. Second is it has to protect itself and not crack or something because, again, the nuclear bomb is a really powerful device and we don't want that to affect the other components. So it has to have, again, a lot of shielding. So these 2 could be 1 point together. And the last point is it has to propel the spacecraft in. If it fails to propel, then that's it. We're not going anywhere. Alright, so after we have figured out a way to propel our spacecraft, how do we make a spacecraft and what all are its features? So, the spacecraft is going to be named Starship. That's my own imaginary name, guys. And to make the spacecraft, we have to make a township or something. You guys know big companies have townships. So yeah, we're going to make a township. And to have any chance of making this, the world has to forget about money and work on a common good. Well, I don't think that's happening anytime soon because whatever, dude, but money, if that eventually happens and there is some treaty signed up, the township is going to come, all these engineers, scientists, and everybody's going to be there with their families and they're going to be working on it. We cannot assemble this whole thing and send it to space. Like the International Space Station, we have to assemble it in space. Which is a pretty good idea because then we could make smaller segments of it and assemble it in space altogether. Let me estimate this will take over 10 years easily, and even if we have funding problems, could be delayed. Because even the International Space Station, Hubble Telescope, and all these big projects have been delayed by 7 years, 8 years, 10 years, and the James Webb by 20 years. So, let's just say we're able to do this in 25 years. Alright, so 25 years is a long time. We're able to pull this off in 25 years. There's again a problem. Human beings cannot reproduce in low gravity environments. You guys have seen these astronauts go into space for about a month or two and then coming back not being able to stand up. We're going to be in space for over 88 years. So imagine that. We would have completely changed the way we walk. And offspring who have developed in such environments, they won't even look like humans. They have so many other characteristics which humans need, but they don't need it because they don't live in gravity. Luckily, back in the days in 1920s, a German scientist showed us that gravity could be replicated if we could make something spin fast enough. So I think we could make two cores of it, like two plates of it. The outer plate could rotate fast enough to generate gravity inside it. So we could potentially save that. And human beings could reproduce normal offspring. Next thing is how are we going to power light? This is pretty easy because we could just put a huge iron rod across the ship and power it with light. And the next thing is, what about oxygen and water? How can we take so much oxygen and water with us? Well, the key lies in itself. So you guys know that water is H2O and has oxygen molecules in it. Just combine electricity with water and the end product is oxygen. Take enough water with you and have enough plants to do the water cycle and you're good. So you could potentially take that with you. Alright, I just have to tap my screen and refresh my phone every time in a while, so yeah. Alright, next thing is we cannot eat meat on the spaceship because, well, there are reasons that meat will rot and stuff like that, so we could eat chicken flavored, non-veg flavored stuff, but we cannot eat meat itself. You can eat worms, so there might be new stuff like worm salad or something on that thing. I don't know what's going to happen. I don't know how situations are going to change on what we eat, but yeah, we're going to develop something like that. And finally, who's going to go? Look at the crowd on Earth. There's so many people, and we could only carry 250,000 people on this voyage. So it comes to the point of money and power, basically. All the rich people are going to go, and it comes to the point where wars are breaking out in countries for people to go. And it's going to be horrible to choose those 250,000 people who are going to go. I know for a fact that wars are going to break out. And it's going to be bloody for the people who are going to go. So much hatred and emotional attachment. You're going to leave your family members behind. Maybe you couldn't take your grandmom, but you have to go to succeed your human race. Well, even if we go, we're going to take 1 trillion other organisms with us. I'm talking about bacteria. Without bacteria, humans wouldn't have existed, nor would this whole ecosystem and ecology on Earth. Taking bacteria is so vital for agriculture and other importance of humans. We have to take a lot of bacteria with us too. Alright, right now we have achieved a little bit. We have entered we have successfully made the spaceship. We have all its features, which are capable enough to take us to TRAPPIST-1, 40 light years away. And we have selected the humans which are going to go, leaving the other 7 billion behind. Now there's a problem. We'll have so many different people from so many different cultures, nationalities, and so much. What kind of government are we going to implement there? Honestly, when I heard this, I was a little confused, saying, you guys have to make a modified government. We can't just put the government of the United States in there, or India in there, or Mexico, or name it. But we can't do that. We have to modify the system according to our needs. Obviously, even if the governor is 50, he won't be around by the time we reach. So we need a strict policy, because on this thing, we don't want anything to go wrong. We have to live in like a huge family there. So what I think is they have to modify the system a bit. Obviously, democracy is going to be the major thing there. But we do have to modify this a lot. Maybe one thing is better than the other in dictatorship, or maybe monarchy. There's something better than democracy. We have to add that in democracy and modify democracy in such a way that we can adapt to situations millions and millions of miles away from home. Or if there is home. Alright, so right now we have achieved everything we need for this voyage. We have a strict government. We have the people who are going to go. We have their food and water. We have light, and we have a spaceship which is capable enough to take us there. And also we have a destination to go to. Now what's going to come? When we get on the ship and the ship starts propelling, everything's going to be fine for a few days and blah blah blah. And when you look back at Earth and you see the neutron star come on Earth and Earth being destroyed, you remember those things. You remember home Earth. You remember all these things you enjoyed here. Okay, some things can happen. When Earth gets destroyed, all the Earth particles can rotate the neutron star and become rings. Or they could go all the way in space and destroy and can cause disruption in the solar system or something like that. Sorry. And when all these things happen, it is quite emotional to think about it. I mean, if you're a practical guy, then nice, but emotional people will have that drawback. Alright, so now let's fast forward in time. 88 years. We have reached our destination, TRAPPIST-1, which has 3 planets in it, and we're just about a year in for ending this journey. What's going to happen? The people who were there in their 50s would not have been around, obviously. 50s, 60s, and 40s. Their children would be in their late 80s and 90s, and most probably wouldn't also be around. It's the grandchildren who'll be in their 40s and their children in their 20s. So your great-grandchildren are the ones who have the future in the hands. So the ones in the great-grandchildren, once you reach the planet, we have another problem. What's the another problem? The other problem is 50 miles an hour wind on Earth is devastating for us, right? Most planets have 200 miles an hour winds consistently. So what are we going to do? Well, we cannot do anything about that. Take all the calculations you have on Earth, trust your math, trust the science, trust your physics, and just go for it. And hope there's no winds there. Like, there's winds, but, not those horrific ones. If we land there, and if you go to, let's say, a TRAPPIST planet F or something like that, yeah, there are 3, so if you go to F, and you find aliens there, hopefully they're not as advanced as us or even more advanced than us, and they are able to persuade us back out of the solar system. If that happens, then that is pretty horrible. Hopefully they're in the times of the kings and queens and having spears and arrows and bows and swords and stuff like that, and we are able to just shoot them out. Hopefully killing is not a way to resolve this. We need peace to make it a long-term way to settle that planet, but yeah, it is a way we have to implement. We have to use pressure and force. We have to build boundaries. We have to kick them out. We have to build a huge fence and throw them on the other side, and we have to confine ourselves. Well, I remember seeing this movie called Moana. I don't know if you guys have seen it, but Disney Moana, I remember having this that Moana has this thirst to cross across the reef, and her dad doesn't allow her to do that because it's really dangerous. Imagine the children who grew up on that planet. I mean, this is not related to the topic at all, but it is a bit. I'm gonna go into this and have a glimpse on how their future will look like and what they will think. Imagine confinement. There's a huge two walls, and then other side is those aliens, and we're over here. Those aliens are protesting to leave us out or something like that. That child is always curious, asking his parents, why aren't I allowed to go there? Why am I confined to my surroundings? And they'll be like, there used to be this planet where we originally came from. We are not from this planet. If the human race has to survive, we have to move around in the cosmos. We don't exist on this planet. We just came, and we are the ones who are causing the trouble over here. And you just imagine that feeling. Having been left home, and home doesn't even exist anymore. Well, it is quite a hard feeling to go through, but we have to somehow make it. And if you're very emotional, you will break apart. I'm going to tell you that. I'm practical enough to survive. And even practical people will have a second thought in their mind or something. Just imagine everything, every person in this every living being call this place home. Without Earth, we wouldn't have been here. Without Earth, we wouldn't have even known anything. And Earth is the thing that gave birth to us, and it's not even there anymore. We will have a second thought in our mind or something, and emotional people will just break down. I don't know about it. Depends upon the situation that time, guys. But yeah, this is how it's gonna look like. This is like the basic skeleton I gave you guys of the escape of humanity, guys. So I like to thank National Geographic Channel for this, because the series RV Alone actually helped me get this idea of inspiration to start off this new series called RV Alone on my channel. I am not plagiarizing, because huge shout out to them. But yeah, hopefully you guys are gonna watch them and learn something. These people are amazing, and hands off to them. Anyways, guys, thank you for watching this video. Hopefully you guys enjoyed and learned something. I enjoyed even more making this video. And yeah, it's just amazing to think about all these things which are gonna happen. And I wish I was born a little late, honestly. I could be a part of this, but right now I don't have any idea what's gonna happen. So this is a skeleton of what's gonna happen, and astrophysicists like in National Geographic actually have said we're gonna have to plan something like this out quick. So anyways, guys, thank you so much for watching. Subscribe to this channel if you have not at all subscribed yet. Like and share with your friends and family. I enjoyed a lot. Alright, guys, thank you so much for watching, and if you guys enjoyed, see you in the next one. Bye.